Hey everyone, welcome back to the channel. Today I wanted to experiment and start a new series, and it's going to be called Detection Deep Dives, right? And the main goal of this series is to take certain interesting or high profile attacks or campaigns and see what we can do about them from a detection perspective. So let's dive in. And so, what is Shai-Hulud? It's an active NPM supply chain attack that started around November 24th. And as of recording this video, it's still ongoing. And the scale is quite massive. There's hundreds or thousands compromised NPM packages with hundreds of millions combined monthly downloads. And we're not talking about like some random packages here. This hit major players like Zapier, PostHog, Postman. They all had packages temporarily compromised. If you're running NPM in your environment, there's a very real chance something in your dependency tree was potentially affected. Right? And what makes this interesting from a detection engineering perspective is that it's a second wave. Right? The attackers learned from their September campaign and came back with enhanced automation and scale. So let's try to walk through the chain, because understanding the attack flow is critical for building effective detection. So the attacker gains access to NPM credentials, usually through phishing campaigns or leaked tokens. Once they have valid credentials, they publish malicious versions of legitimate packages with a modified package file that includes a pre-installed script. When a developer runs npm install, that pre-installed script executes immediately before the package is even fully installed, which is the key point here. The malicious script downloads and installs bun, which is a legitimate JavaScript runtime, and uses it to run an obfuscated payload. The payload scans the local file system and cloud environment for secrets, API keys, GitHub tokens, NPM credentials, AWS keys, you name it. They're using tools like Trufflehog to automate this secret scanning. And where it gets interesting is instead of exfiltrating to a traditional command and control server, the malware creates a public GitHub repository with a very specific description, which as of right now is Shai-Hulud, the second coming. All the stolen credentials get uploaded there. And it's quite good for the attackers because, GitHub traffic looks legitimate. So unless you know what you're detecting, it kind of blends in with legitimate traffic. And after that, it is using the stolen NPM tokens to publish itself up to 100 packages per infected developer. This is what makes it a worm, right? It spreads automatically without attacker interaction. And there's also the persistence mechanism where they install GitHub self-hosted runners, which I was not aware of before. So I learned something new in the recent days. And we're going to see how we can start to detect this. So let's start with bun installation via invoke REST method. So I have my lab here, and I have everything prepared. So what we're going to do is to run a command and monitor the telemetry to see what we get and how we can detect it, right? So the first command that they used is this one. Now, I want to make a point here. You see there's a space here at the end, which is not present in the research I've read. Let's take a look at this. Now, you see, the reason there's no space here after the IEX, the reason I want to show this is I've used the new tool I created, Lumen, a few days ago, and there's a video about this too. And I wasn't able to initially understand why I'm not getting a detection for this, because, you know, there is a sigma rule for invoke rest method. And I saw that in the sigma rule, they only detect this activity if the IEX contains a space after, or, you know, it's written in any of those formats. But this is not what the command is doing. So if we run this without a space, Lumen is not going to be able to detect this. But if we do it with a space, then it's fine, right? Because I uploaded the EVTX file, and now I'm able to see. You see, there's a space here, and it's getting detected as it should. So for Windows, it's going to use this command, and it's quite easy to detect. We're looking for variations of invoke rest method. You can include the IEX like they did here. We can see how it looks like. I have my Splunk instance running. Right, so we can see the command, and this is one avenue of detection, which is rather noisy, I would assume, especially if you're a developer shop, or you have a developer department. So you might want to baseline this activity and see how you can make the detection more atomic. The next thing I want to go over is, I'm going to skip the child processes for NPM because it's a very noisy detection. But the general idea is, if you have node spawning command line interpreters, which is kind of what it does all the time. So I decided to skip this and go straight to GitHub self-hosted runner. Now, a self-hosted runner is, in the context of this attack, is the persistence mechanism, right? So what the attacker can do is install a self-hosted runner and send commands to it. It's like a command control server. So I have a demo repository here, and we're going to create a runner. So I already downloaded the archive, so I'm just going to go to the directory and copy this. Now I want you to also see what we're getting on procmon to exactly see the telemetry. Right, so it's going to ask us for some details. I'm going to use the default. I'm going to set it as a service because it's also another avenue of detection. Okay, so when we install the self-hosted runner, we can see that we have multiple instances of runner listener. We have services being executed to install the service, and runner service. So this is a great avenue of detection, right? If you have runner listener spawning, and it's, you're not using self-hosted runners, this is something that needs to be checked. Right? Today I also submitted this variation of a rule to the Sigma repository as a pull request. The runner and the worker, right? There's two related processes. The worker, we're going to see how it acts, right? So let's run this first. And now it's basically started listening for jobs. So let's go ahead and create our workflow file, which is going to tell our machine which commands to run. So it should be .github workflows, and we can call it whoami YAML. I'm gonna copy this, paste it here. Okay, so now what we can do is go to actions, and you can see that it's working. Okay, good. So now we can see that the telemetry changed and we have the new worker process. And the worker process is spawning PowerShell, right? You can use the spawn client flag to detect this more in a more focused manner. And what PowerShell does, it's running a script from the directory of the self-hosted runner, right? And what the script does is basically it's running the command, which is whoami. So there's multiple ways to detect this. I think a good place to start would be some variation of this query, which, you're looking for any usage of runner worker or runner listener. But again, like depending on the environment, it might be really noisy. So you can take a look at the pull request I created. This one. And you can see, my variation. So I tuned this slightly better by including certain command lines, but you don't have to do this. You can just start with a very broad query and scope as needed. Cipher, that's also something you can detect on, but it might be too late at this point. I think it's using this as a last resort, right? It's going to delete your entire system, home system at least. I think I don't remember exactly where I saw this. I think it was the Datadog article, maybe. Or the GitLab one of those two. Yeah, there you go. So on Unix it uses shred, and on Windows it uses Cipher. Now, I'm not sure if Sigma is, they have something for Cypher because Lumen did not alert me on this. Yeah, they do. Okay. Oh, so yeah, you have to use a specific command line, you see. Let's try to simulate this, right? Because I want Lumen to show this. So I'm going to do Cypher w test. Okay, so now the command is logged. I'm gonna go to my event viewer and filter on process creation. Verify that I got this, which I did. The command line is this one. Okay, so now I'm going to export all of my process events and run Lumen against it again. And I should get now the Cypher detection, hopefully. I'm kind of doing this as I go. I don't like to be too bound to a script, so hopefully it wouldn't be too long. Yeah, there we go. So now we get the Cypher detection. But to be honest, if you're like at this point, it's like too late already. But still, it's a good detection to include because you know it might not be used exclusively by Shai-Hulud. So there's another something you can do. Now, registry service creation, this one is a bit of a tough one because it's a very noisy like activity in general, but you should be aware that it's going to start a service. It can start a service if you configure it to, and the image is going to be services.exe, and the naming convention is something like this, right? It's actions.runner.whatever. So this is something else you can detect on, but I'm pretty sure that Shai-Hulud does not act as a service. It installs itself as an unattended self-hosted runner, right? So these are the two sources I've analyzed, and actually yesterday I decided to take the leap of faith and open Lumen as a open source project. So you can check out the code and you know, if you want to participate and contribute something, you can definitely do it now. You can find it here. I'm gonna put a link to the description. But yeah, I hope you learned something new from this video. Let me know if it was too fast, too slow. I kind of aimed this towards hopefully not too high of a skill cap level, but I also did not want to do this like for extreme, you know, beginners, because like I wanted to find a middle ground somewhere. But that's it for this video. I hope you enjoyed, and if you have any feedback, let me know, and hopefully I can make the next ones better. So thank you for watching, and I will hopefully see you next time.